In this video, we'll look at how to graphically solve a system of linear equations. In this problem, we're asked to graph the system below and write its solution. We're given the two linear equations, negative 2x plus y equals 7 and y equals 1/3 x minus 3. Now, my goal here is to graph the two of them. So what I would like to do is get this first equation into the form y equals mx plus b so that I can graph its y-intercept and use its slope to get a second point. So I'm going to go ahead and solve this for y, and I will have y equals 2x because I have to move the negative 2 over, and then plus 7. All right, so I have both of my equations in the form y equals mx plus b. So the first equation, I'm going to go ahead and use that 2x plus 7. So my y-intercept is 7. I'll put a dot there. And then the slope is 2, which would be a 2 over 1. So my rise is 2, I go up 2, and my run is 1, I go over 1. And then I'm going to go ahead and connect those two. So I have my y-intercept and then up 2 over 1 to get my second point. Now, my second equation is y equals 1/3 x minus 3. So that gives me a y-intercept of negative 3. And my slope is 1/3. So my slope, my rise is 1, and my run is 3, 1 over 3. So I go up 1 to the right 3, and that gives me my second point. I'll go ahead and connect those. So there's the graphs of the two lines. So now what I want to do for the solution is look at where the two lines cross. So I need an x value and a y value. The x value is negative 6, and the y value is negative 5. So the point where the two lines cross will be my solution. So I'm going to put an ordered pair of negative 6, negative 5, and that will be my solution. Okay, so let's try another one and do the same thing. So here I have y equals 3x minus 2 and negative 6x plus 2y equals 0. So I want to graph both of them. The first one is going to be fairly easy. It's already in slope-intercept form. It has a y-intercept of negative 2 and a slope of 3. So I go up 3 over 1. So there's my first line. Now the second line is the one that I will need to change to be into slope-intercept form. So let me grab my pen. I'm going to solve for y. And I start out with negative 6x plus 2y equals 0. And I'm going to go ahead and add my 6x to both sides. So I end up with 2y equals 6x. And if I divide both sides by 2, I get y equals 3x. So that's my second line, y equals 3x. And when there's nothing added on there, that tells us that the slope is not the slope, but the y-intercept is 0. So I'm going to have a y-intercept of 0, 0. The slope is 3, so I'm going to go up 3, 1, 2, 3, over 1. There's my second point, and let's connect that. So I have a y-intercept of 0, slope of 3, so up 3 over 1. These lines are parallel, which tells me that they will never cross. So that would be an example of no solution. So I'm going to come down here and select no solution. All right, so if they cross at a point, that point is your solution. If they're parallel, then that's no solution. If they end up being the same line, then they give infinitely many solutions. Let's do one more and then we'll stop. So here's one more. Okay, so we have 2x plus y equals 3. And I want to go ahead and get that into slope-intercept form. So I'm going to go ahead and solve it for y. So if I solve for y, I get y equals, move the 2x over, so negative 2x plus 3. And then, of course, my other one, y equals negative 1/2 x minus 3. So I'm going to have a y-intercept on this first one, a y-intercept of 3. And then a slope of negative 2. A negative slope goes down and then to the right. So negative 2 goes down 2 and to the right 1. And then my other line is negative 1/2 x minus 3. So that is a y-intercept of negative 3. A slope of negative 1/2. So my rise is down 1. My run is to the right 2. And that will be my second line. So now I'm looking for where the two cross. The x value is 4 and the y value is negative 5. So this would be at the point 4, negative 5. All right, so again, if they cross at a point, that's your solution. If they're parallel, there's no solution. And if they end up being the same line when you get them in the y equals mx plus b form, then there's infinitely many solutions. To graph, it's easiest to put it into the y equals mx plus b form, and then use your y-intercept first, and then your slope of rise over run to get a second point.